Hi, this is the third of three videos on using a fast and intuitive method for finding quick answers to kinematics problems. This one is going to be focused on projectile motion problems. So in order for this to make sense, though, you're going to have gone through this one on free fall. And before this makes sense, you'll have to have gone through this one on kinematics. So I'll try and put links to these on the video description so that you can easily find them. Alright, so just like the other two videos, there's going to be an assumption that gets made, and that is that air resistance is going to be negligible. We're going to ignore the effects of air resistance for this. And the acceleration, we're going to bump up to negative 10 meters per second squared so that the calculations are much easier. So this will actually help you make quick estimations. It will help for things like multiple choice questions. Even if the numbers aren't nice and easy, they will. You'll be able to get close to the answer. And just as a check too for when you actually do the more rigorous problem solving. So this system works for some problems, not all problems. It depends on what you're given. But okay, let's get started. So we're going to use the exact same thing we used for the other two. Imagine that we fire something in projectile motion, and let's say that when we do that, the angle that it's fired, if we use some trigonometry, sines and cosines, we can, with this angle and knowing this magnitude of the velocity, we can find the x and y components. So I'm just going to make the x and y components 30 meters per second and 40 meters per second. Just going to make them that. Okay, now, so with this then, I can easily find out how far down range it's going to hit if it lands at the same surface that it was fired at. Say like a soccer ball that's kicked and then goes downfield. So I can easily find the range, and I can also find the maximum height that it's going to reach. Okay, so to do this then, let's just look at the y component at 30 meters per second. If we just fired something straight in the air at 30 meters per second, the thing about projectile motion is that the x and y components act independently. And so if we just fire something straight in the air at 30 meters per second, after 1 second, it'll be going 20 meters per second in the y direction, and then 10 meters per second, and then 0 meters per second. So it's actually going to take 3 seconds to get up to the top, and then coming back down, it will take another 3 seconds. So I know that the time, the total time for the trip, delta t, for the trip, using the y component, is going to be 6 seconds. Now the whole time then it's going 40 meters per second, and there's no acceleration in the x direction. So if you go 40 meters per second for 6 seconds, your total range is going to be 240 meters. Every second you go 40 meters. So you're going to go 240 meters in 6 seconds. Okay, and what will be the maximum height that it reaches? Okay, well, it's going to take 3 seconds to get to the top. And looking at the y component, your average velocity, you're going to have a 0 meters per second at the top in the y direction. You're going to have a 0 meters per second in the y direction. And it started out at 30 meters per second. So the average velocity is, just add these up and divide by 2. So the average velocity is 15 meters per second. On average. Now if it was going on average 15 meters per second for 3 seconds, the time it takes to get up there, then the maximum height that it's going to go is going to be 3 seconds times 15, so it's going to be 45 meters. See how easy that is once you get the hang of it? Okay, now you might say, well, but what if you don't have nice easy numbers? We'll just round them just to give us an idea, an estimate of what we're doing. We're already rounding the 10 meters per second squared. So, okay, let's try another one. We're going to find the range and the range that this is going to go, and we're also going to find the maximum height it's going to reach. Okay, so if you want, you can try doing it on your own by pausing the video. Okay, so it's going to be going up for 1 second because it loses 10 meters per second in the y direction every second. So it will go up for 1 second and it'll take another second to come down. So your total time in the air is going to be 2 seconds. The whole time you're doing that, you're going 40 meters every second. So your range, your delta x, is going to be 40 meters per second times 2 seconds. So that's going to be 80 meters. Okay, what about the height? Okay, well, you started out with an initial velocity of 10 meters per second, and then to get to the very top up here, it's now going to go. It's going to have a final velocity in the y direction of 0 meters per second when it's at the top. It's not moving in the up or down. So your average velocity in the y direction is 5 meters per second. And that's doing that for 1 second. If you went up at 5 meters per second for 1 second, you'd go 5 meters in the air. So the height is going to be 5 meters. So this is pretty fast to do once you get the hang of it. If you're not actually explaining it to somebody, but you're just looking for the answer, it's a really quick way to get the range and the height. Okay, I'd like to point out something here. So the last one was the opposite of this. So the y component was 10 and the x component was 40 meters per second. Well, we're going to switch these around, which means that this angle is the complementary angle of the other angle. So whatever this angle was, if this would be 90 minus that angle. We know that complementary angles, well, if it's going to hit the ground at the same level it started, complementary angles are going to give you the same. It's going to give you the same range as before. So I already know the range of this. It's going to be 80. It's going to be 80 meters, but it will give me a different height. It's going to go up higher. This one is going to only go up a little bit because it's being fired up at 10 meters per second, whereas this one's being fired at 40 meters per second. All right, so let's figure out how long will this be in the air. It's going to be going up for 4 seconds because it loses 10 meters a second every second, and then it'll take 4 seconds to come down. So the total time in the air, will be 88 seconds. And if you go 10 meters per second for V average times delta t is your delta x. That is your range. So that's your delta x. And so that's going to be your average speed. Since you're always going 10 meters per second, it never changes. 10 meters per second times 8 seconds. Seconds cancel, and you're left with 80 meters. Okay, how high up will this go? You want to pause the video and see if you can figure it out? Okay, so it's going to be going up for 4 seconds. Its average velocity, it starts out at 40 meters per second in the y direction, and then it ends up going 0 meters per second in the y direction. So the average velocity in the y direction is 20 meters per second. And so if you go 20 meters per second on average for 4 seconds, you're going to go up 80 meters. So your delta y max, or your height, you're going to do 20 meters per second times 4 seconds is going to be 80 meters. So it goes way up there. Whereas the other one only went up 5 meters. The other one went up 5. All right, let's keep doing this just to give you a bunch more examples. All right, so we got 20 meters per second and 30. You know, you can use trig to get these, to figure out what these are, and then you can round them. Okay, so let's see. This is going to be going up for 3 seconds because it's losing 10 meters per second each second, and it's going to take another 3 seconds to come down, and so the total time in the air will be 6 seconds. And it's going 20 meters per second the whole time. So the average velocity, delta x, is going to be the average velocity, 20 meters per second, times the time, so 6 seconds. So it's going to go 120 meters downrange. How high up will it go? Okay, this distance, I'm going to use the y component. If I fire something up at 30 meters per second, that will match the same height as this projectile. So let's see, the average speed is going from 30 meters per second to 0 meters per second in the y direction. This is your initial and your final speed. So your average velocity in the y direction is 15 meters per second. And that's happening for over 3 seconds. So your delta y, your maximum height, is going to be, if you go up 15 meters per second on average for 3 seconds, you're going to go 45 meters up in the air. All right, let's do another one. These are just more. The last one will be slightly different if you want to wait to that. I'm just going to do some more examples you can practice. Okay, this will be in the air. This will be going up for 2 seconds, down for 2 seconds, so it'll be in the air for 4 seconds. And it's going 60 meters per second, so the range, the whole time it's in the air, it's going 60 meters per second, 60 meters every second, so it will be going 240 meters. That's how far down range it's going to go. And the height that it's going to go, let's see, looking at the y direction, our initial velocity in the y direction is 20 meters per second, but at the top it's 0 meters per second. So the average velocity in the y direction is 10 meters per second. And if you do 10 meters every second for 2 seconds, it's only going up for 2 seconds. The other 2 seconds it's coming down. So then it will have a height, the maximum height that it's going to reach is 10 meters per second times 2 seconds. So that would be 10 times 2 is 20 meters in the air. All right, just 2 more examples. The last one has a little bit of a twist. Okay, so this again is the complementary angle for this. So I'm going to do 60 and 20 now. So we know that the range has to be the same for complementary angles. So I'm going to get 240 for the range, but my height's going to be much higher because it's got a bigger y component. So let's see, this is in the air for 12 seconds. So your time in the air is 12 seconds, 6 up and 6 down, so that's 12 seconds. And you're going 20 meters every second that it's in the air, so that's going to be 240 meters. Okay, what about the height? Well, you're starting out with an initial velocity in the y direction of 60 meters per second, and your final velocity is 0 meters per second at the top. At the very top, it's 0 meters per second. So your average velocity on the way up is in the y direction is 30 meters per second. Okay, if you go 30 meters every second for 6 seconds, then you'll go 30 meters per second for 6 seconds. You'll go 180 meters in the air. You're going way up there. All right, last one. So now these are some numbers that are a little weirder, more realistic. And let's say that they didn't even give me this. Let's say they gave me the magnitude and the angle. And so I quickly use sine of theta equals opposite over hypotenuse to get this one, and cosine of theta equals adjacent over hypotenuse to get that one. Okay, so now I'm just going to round this to 20. And so this is going to be in the air about 2 seconds up and then 2 seconds down. So it's going to be in the air for about 4 seconds, a little less. So delta t will be a little less than 4 seconds. And it's going about 20 meters per second, so the range is approximately, I should put approximate signs for all these, right? Because this is 10 meters. This is using the acceleration due to gravity is 10 meters per second squared. So the approximate range, 4 times 20, is going to be about 80, a little over 80 meters per second. And probably will be about 80 meters. Excuse me, not meters per second, but 80 meters. Okay, how high is it going to go? Well, it starts out going almost 20 meters per second in the y direction, and then goes to 0 meters per second at the top. It's not moving in the y direction. So your average velocity in the y direction is 10 meters per second. And it does that for 2 seconds to get up to the top, so that the height is going to be approximately, if it takes 2 seconds, it'll be 20 meters. Okay, so that's just a really quick way to get projectile motion problems and the test for them, to see if all the math that you did actually worked. All right, see you next video.